Hi guys, today we will discuss what does the controlling for other factors mean in regression analysis. You think some factor is associated with a condition. For example, high blood sugar level is associated with myocardial infarction. You want to conduct a study where you will record person's blood sugar profile and the incidence of MI. Will you be able to associate blood sugar with MI? No, because heart attack is likely caused by multiple other factors. If you only record the sugar level, you will not be able to tell if the association seen between sugar and MI is real or not. The answer is control for other likely variables like blood cholesterol level, smoking history, etc. We today run an example of regression analysis on fictitious data to show how the result is different without the control and with the control. Here we have a data on history of alcohol intake and occurrence of myocardial infarction. We want to see if the alcohol intake is associated with myocardial infarction or not. Altogether, we have data from 1120 patients. We have conducted a binary logistic regression analysis in R and posted the result in sheet here. We are looking for the association between alcohol and MI. We see that the association is hugely significant and alcohol intake is associated with 1.8 times increase in odds of MI. But someone may say that smoking is highly related to myocardial infarction and you must control for smoking. So now let's also consider the history of smoking. Here we have also the data related to history of smoking. Now we can see what is the effect of alcohol on MI after controlling for effect of smoking. So we conduct the binary logistic regression again, but now both alcohol and smoking as the independent variables. We see now the alcohol intake is not associated with MI at all because the p-value is one which shows a very insignificant association. The odds ratio is also one, which means the alcohol intake has no effect on odds of myocardial infarction. But we see that the smoking is highly significant variable in a model. The history of smoking is associated with 4 times the odds of having myocardial infarction compared to people who do not smoke. We saw how controlling for other variables may change the relationship completely. But how do regression analysis control for variables? It decides the coefficient for each variable while keeping the effect of other variable constant. To do so, it uses linear algebra, matrix, and derivatives. Odds ratio is calculated from the coefficient. We can see how control variables alter the effect of our interest variable by visualizing the effect separately for each level of control variables. Here we have a cross-tabulation of alcohol with MI. We can easily calculate the odds ratio by multiplying 640 with 100 and dividing the product by product of 160 and 220. The odds ratio of 1.81 is same as calculated in univariable regression analysis. Now we look for the effect of alcohol stratified by level of smoking is no and yes. We see that for both level of smoking, the odds of MI with alcohol is 1. So when adjusted or controlled for effect of smoking, the relationship between alcohol and MI changes. At this point, it is important to appreciate that while controlling for effect of smoking, alcohol intake was not associated with MI. That does not mean the relationship between smoking and MI must also change when we control for effect of alcohol intake. Let's see that on action. Here we have a cross-tabulation of smoking with MI. The odds ratio is 4. Now we look for the effect of smoking stratified by level of alcohol intake as no and yes. We see that for both level of alcohol intake, the odds ratio is 4, implying the odds of MI with smoking is 4 times the odds of MI without smoking. So when adjusted or controlled for effect of alcohol, the relationship between smoking and MI remains the same as in univariate analysis. At this point, one may wonder what distinguishes independent variable and control variable. After all, they are both treated equally in regression analysis. And of course, the order of entry of variables into regression analysis does not change the adjusted relationship between variables. The variable of interest in our research, which we believe is associated with outcome according to our hypothesis, is the independent variable. If we believe other factor is also associated with the outcome, we adjust for factor or include the factor in regression analysis, and we call that factor or variable a control variable. Lastly, to conclude, regression analysis provides us the estimates for every variable that are included in the regression analysis. This estimates for each variable are adjusted for the effect of all other variables included. The adjusted estimate example. Odds ratio of a factor show relationship between factor and outcome with effect of all the other factors kept constant. All the data files shown in this video will be shared via the link in the description section. We encourage users to play with this data and appreciate the results themselves. Thank you.